Hello everyone, I'm Sanskriti Kadam and today I'm going to walk you through my newest publication, which is a journal based on a lightweight CNN model for cotton leaf disease classification. So let's get started. This project implements a lightweight convolutional neural network, which is based on the classification of a cotton leaf diseases. Here, the data set which we have made use consists of three diseases like bacterial blight, cotton curl virus, and fusarium blight. And our goal is to help the farmers and all the agriculture people to understand what measures they should take so as to prevent a disease being spreading. So why does this matter? So this matters because it enables an early diagnosis to, to reducing the crop loss. Also promotes the cost effective, which is very much important in agriculture. And it supports a field level implementation, which is based on low resource devices. So as mentioned, the data set that is being used here consists of three types of diseases: bacterial blight, cotton curl virus, and fusarium blight. So the images are pre-processed, resized, normalized, denoised, and also augmented for getting an improved accuracy. The technologies which we have used here are Python, TensorFlow, Keras for CNN model design, which is very important, and Pandas, Matplotlib, Seaborn for data analysis and visualization. Here, Pandas is to getting the data set imported and visualizing the data set, whereas in Seaborn, it helps in the plotting of the different type of labels like X and Y labels, which I will show you in the forward part of the code of this video. Even the evaluation matrix, that is accuracy, precision, recall, and fun score, which we can understand from the whole classification code. So the results which we have got is a 96.6% of accuracy on the test data, and also validated the matrix like precision recall advance score is greater than 95%. And we also encourage the people, those who want to uh, build more and more possible means future technologies in this kind of domain. You can fork this whole code and also introduce some of the IoT integration, that is making use of sensors and drones for automated disease monitoring in large scale farms. Also, mobile app integration, like building a real time plant disease detection tools just via mobile phone, which is very accessible and cheaper for the farmers. You can also extend the data set by increasing its size, or let's say, or putting some more types of diseases in the apart from these three diseases, and using a real world field images for increased generalization. Also, making use of satellite and AI fusion is a very brilliant idea which you can use in this project. Now let's talk about where you can view this publication. So here I have mentioned the link of the publication in the about section. Even there is a PDF of this publication which is committed here, as you can see, committed PDF. And after the publication of any journal, you get an acceptance letter. So let's go through the code first, and I will later show you how the acceptance letter looks like and what is a PDF about. So this is a code. As you can see, the libraries are being imported, and NumPy, Pandas, Matplotlib, and a lot. Then you need to change this dir link as per the local system. And then the data has been imported, the images are been converted into arrays, that is binary of 0, 1, 2. Then you are using NumPy to normalize, so that you can able to get the images in a very different format, which would be easy for you to split it into test and train data on the basis of the parameters like test size and random state 10. Now, this is a CNN model building, which you can see. We have made use of layers like convolutional 2D, max pooling 2D, convolutional 2D again, and dense and flattened layers. Also made use of activations like reduce, softmax, and the loss as well, which we call as categorical cross entropy loss, even with using another type of parameters like add-in and mentioning the number, which would be very much feasible for you all to do that. And then training the whole data set uh, under the 128 batch size into 70 epochs, and then fitting the model based on these parameters, and then getting the summary, and here we go. The output looks somewhat like this. This is a model summary where you can see the layers which is being used and the output shape and the parameters which accommodate to the particular layer. So once you run all the epochs, all the 70 epochs, it might take a bit of time as per your system's capability, but you can try that. Even using epochs, like the number of epochs is a trial and error. So let's go to the last epoch. Yeah. So here we get an accuracy of 0.9529, that is 95%. And also validation loss and validation accuracy, but we will consider this kind of accuracy which is being given over here. Next, now it's time to visualize the training on the hard work which we have done by using charts. Here we make use of two charts, that is having epoch versus accuracy and epoch versus loss. So this is how it looks like after you are using the visualization code. Train and validation, you can see it has been differently colored, and you can see the trends which is being going. Now let's do one more thing, is like you are ensuring that all the arrays, the input arrays which we have, are of same number of samples. Now this is done through this code, as you can see. Again, loading the structured data, making it target labels, and splitting the features targets. Again, splitting the data into training, test, and a lot of the thing is been done over here. Now, why we have done is to get a confusion matrix. That is, we plot the confusion matrix. Now, as you can see, this X label and Y label is predicted, and actual and title is confusion matrix. This code is being giving us a confusion matrix in a form of a visual, but you can't see that in the output, just this plain part you can see. This is because when we are trying to execute this, the output, then is the image of the confusion matrix, gets stored separately. So I will show you how it looks like. So this is a photo of the confusion matrix which the code has given us, a dummy confusion matrix. As you can see, this is a true label, and then this is a predicted label. This is a range of the, values, and here you can understand the false negative, false positive, true negative, and true positive, and you can also calculate the accuracy, precision, recall, and a lot of stuff through this confusion matrix. Now let's talk about where you can find this journal. So first is a PDF which you can directly download just by poking this whole GitHub repository. It will be downloaded directly in your own local part, that is over here. You can see this is a PDF. Yeah, this is a PDF of the journal. As you can see the introduction and everything. Okay, you can clone this and you can see to it. After publishing the journal, then you get an acceptance letter, and it looks somewhat like this. The journal of critical review is where this journal has been published, and you can see the author's name. As you can see, these are my peers and our respected professor, Mr. Pankaj Sonawne sir, who has guided us in for this particular title paper and for doing this journal. So this is how it looks like. The article is being submitted to Journal of Critical Reviews, and the signature of the editor, everything. You can get this in the acceptance letter. Yeah. Now let's talk about, this is just a PDF. Now it must, if the publication has been done, then there must be a link. So you can find the link in the about section over here, which when you click, then you get routed to this website where it looks somewhat like this. You can see the names of the authors, you can download the articles, you can also check out the abstract, and also you can check out the keywords as well. So I hope that you found this video helpful, and if you have any doubts, you can ask me on LinkedIn as well. Also, you can mention this publication in the link in the publications section of your own LinkedIn profile, as I have mentioned over here. So this is my profile. You can go through the projects and you can ask me any doubts if you have. This is a publication. As you can see, it is being shown. Writing a few lines of description will also help to build your profile in a very perfect way of you showing how much you are into the trends of the technology. So I hope you enjoyed this video, and if you have any doubts, you can ask me on LinkedIn. Also, you can comment down in this video, and let's meet in the next video. Thank you.